Hi everyone, today I'll be talking about the population density of Bengal tigers and what methods you can use to estimate that. So some of the problems with current research is that there's just a lot of different methods being used, and some are just not nearly as effective as others. And this is mostly due to the fact that tigers are incredibly elusive and they live at such low densities that it can be hard to find them. The methods that I'm looking at are track surveys, camera traps, and genetics. So for track surveys, you would set routes to walk ahead of time, you would pick different paths and trails to go on, and you would need to record the location and number of any tiger tracks you found. And you need to make sure you correctly identify them as tiger tracks. So to do so, you would want to measure the print, as well as looking for any identifying marks, such as no claw marks or anything like that. And you would take multiple different track surveys in the area, and then you could use that to get a density estimate for the whole area. So some of the pros are just that it's a very easy setup and very low cost because you're just going out and walking these trails, and you're only paying to have people go walk these trails. So it's a very good cost-effective option, but on the flip side, it is incredibly imprecise because it relies on humans identifying the correct track. And it does require a lot more manpower because you have to physically have people go walk these trails. The second method is camera traps. Now, these are great because you can identify individuals since tigers have natural markings, and they're predators, so they use paths to travel their territory. Now, you could go find these paths by looking for other passive markings like tracks or scat, and then use those paths as a place to put your camera so you get more identifications. And you would want to set up 2 cameras on either side of the path to capture both flanks of the tiger. And then after a certain number of identifications, or after a certain period of time, you could use all these pictures to get a population density estimate by how many times that you caught the same individual. The pros for this is that it's pretty precise. Camera traps can give you a visual way to identify it instead of just looking at tracks or something. And you don't need as much manpower, you just need someone to go put out the cameras and then look through the pictures afterwards. But the setup is a lot more difficult because you have to go set up the cameras and time them with each other so that both of them would capture the flank at the same time. And cameras do have a high initial cost but a lower annual cost because you have to buy all the cameras at the beginning, but then every year you just need to replace or fix the ones that get broken or stolen. And also, cameras can be kind of finicky. The sensors may not trip at the same time, and so you may not actually capture the flanks, leading you to not be able to identify an individual, kind of like in the picture below. So my recommendation is to use genetics by having detection dogs find scat. So dogs find and distinguish tiger scat a lot better than humans. When humans search, only 53% of the scat that they found was for tigers, versus dogs found 76%. And they can search large areas a lot quicker than we can, letting you find more scat and getting more samples to get a better population estimate. And from there, the handler would take samples of the scat and send them all to a lab for DNA testing. Okay, so genetics has a pretty easy setup. You just need to get the dogs and then go search grids. And it's very precise because you're using DNA testing. And so you can get great individual identifications, but you can also get more information than that. If you want to know life history or anything like that, you can also find that out from DNA. But it is got a very high cost. You need to run multiple lab experiments, and you need to have detection dogs and care for them as well. So you need, some manpower to be able to go search these areas, but you need a lot of expertise for the DNA testing. And in general, detection dogs are great, but different dogs can have different results, and weather can impact them as well, impacting the results that you would get. So here are the citations that I used and everything that I got my information from. So thanks for watching. Feel free to submit any comments or questions you have below.